Okay, today let's look at Modulo One. This piece of apparatus from Lascells is brilliant for demonstrating amplitude and frequency modulation, generally when applied to communications. This is often quite a difficult topic to teach, and this allows students to visualise exactly what's going on. The box itself contains a 10 kHz oscillator, which is used as a carrier wave, and that carrier wave can be modulated either AM or FM by an external input or by the built-in mic. To start with, we're going to use a signal generator external input to modulate that 10 kHz signal. So to start with, let's have a look at that carrier wave, and I'm going to plug the Modulo One into my scope here, and there you can see that 10 kHz carrier wave unmodulated. Using the 8 ohm or 4 ohm outputs on your signal generator, you can then input whatever modulating signal you want. So I'm going to put in a 1 kHz modulating wave, and you can see immediately on the scope that 10 kHz wave, the frequency hasn't changed there, but the amplitude of that wave has been modulated at the 1 kHz frequency of the input. This can be demonstrated quite nicely if you take a second lead for your scope and just monitor the output of that signal generator. If I plug this in and monitor on channel 2 and switch this to dual, I'll trigger that on channel 2 as well. There you can see my carrier wave and the modulating wave. So this bright line is the modulating wave, the bunch line is the carrier wave, and as you increase the frequency of the modulating wave, that modulating frequency also increases. You switch back to channel 1 and have a look at that. To get both of these waves stationary on the screen, you're looking for your applied signal to be a submultiple of that 10 kHz. Otherwise the trigger function on the scope is only going to trigger on one of them and you won't get a stationary wave. That's pretty good. If we flick our Modulo One now to frequency modulation, you can see that 10 kHz carrier wave is now being frequency modulated from a maximum frequency to a minimum frequency with the same period as the applied wave. If I again switch to dual, you can see that the tight bunched up wave there corresponds to the trough in the signal, and the spread out wave corresponds to the peak in the signal. The amplitude in this instance hasn't changed. This is a frequency modulated signal. The input can quite happily be switched from external, so we can turn the signal generator off and use the inbuilt microphone to modulate the signal, either frequency modulation or amplitude modulation. This piece of apparatus really does allow students to see what's going on when it comes to the modulation of carrier waves. It's much better than drawing diagrams on the board and makes it much easier to understand. Thanks for watching.